And a very good morning to you. I am here on this soggy day to be talking with you about the kinetic theory of matter. And when we talk about kinetic, this word right here, kinetic implies movement. Okay? Theory is an idea, and matter is what we're going to apply it to. So it's a theory or an idea about how matter is in motion. Kind of like to try to keep those three words in mind. So look at this image here, please. And just take about 10-15 seconds and look at this. If you want to pause the video, that would be a great thing to do. But just examine what kinds of information are you being given from this. And think of three words, which is what I'm going to write down here, that I think of when I look at this. But I'd like you to try to do that first and see how well we can be on the same wavelength. So, my three words. Heavens to Betsy. All right. My three words. I think of the word space. I think of the word order. And I think of the word movement. How did I do? Or how'd you do? Did you match up with what we've got here? When I take a look at space, well, I'm looking at solids right here and liquids. It looks to me like there's about the same amount of space between particles. But when I get to a gas, there's a lot of space between particles. When I think of order, well, solids, look at how they're in rows and columns. There seems to be a very significant order to this, whereas liquids, they're just all, there isn't any order. And with gases, again, I don't see any order here. The word random kind of piles up in my head here, whereas this is very ordered. And when we get to movement, I think you can see from this picture that it's implying that these particles are able to move. These are moving with probably greater velocity, where these are able to move, but they're able to move in a very fixed spot. I think the word that I would use to describe that is vibration. So, what does the kinetic theory of matter say? Let's take a look at that. Whoa, look at all this typing. Holy smokes. The main points of the kinetic theory are as follows. First, matter is made up of particles that are constantly moving. You will hear us talk about solids where the movement is vibrating. Liquids are able to slide across each other. They have that ability to flow, and gases are they're free. And we'll talk a little bit about that in class. Secondly, all particles have energy, but the energy varies depending on whether the substance is a solid, liquid, or a gas. And I would probably say here that solids, let's do that. Solids have typically the lowest energy, liquids are a little bit higher, and gases are the highest energy of conventional matter. There's another kind of matter called plasma. We're not going to really deal with that too much right now. Thirdly, the temperature of a substance is a measure of the average kinetic energy of the particles. And kinetic energy is equal to 1/2 the mass times the velocity squared. Okay? And that's what we're talking about when I say the average kinetic energy. It's the product of 1/2 times the mass of the particle times the velocity of the particle squared. And temperature is going to be something that we use to describe differences between substances, because what can happen here, if I go down to the fourth piece, if we change the energy of a particle, like I change the temperature, what you can get is a change in phase. And a change in phase, a phase is something we call a solid, a liquid, or a gas. So I can make a solid change to a liquid by changing temperature sometimes. And understand that this may occur. And it's one of the things that we'll need to take a look at here, is how this takes place. Fifthly, there are spaces between the particles of matter. And I think we talked about that in the other picture. There's the least amount of space in solids and liquids, and an enormous amount of space when we talk about gases. And finally, 6, there are attractive forces between particles, and these become stronger as the particles move. Holy smokes, I'm missing my words. As the particles move closer together. Sorry about that. There. I feel better. And these attractive forces we're going to use to talk about why there are some differences between boiling points and melting points, freezing points, condensation points in substances. Why doesn't all matter have the same melting point? And that has to do with attractive forces and their impact on these changes. So, do you have some questions? Or better yet, do you have some answers for me? Probably not. We will talk a little bit about this tomorrow. Hopefully you've watched the other video also. And that is pretty comical. Maybe you want to try to do something like that. So, I'll see you tomorrow. Thank you.